Hello, 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 hello. Hello, good evening to all of you. I hope I'm audible and visible to all of you. Okay, so as you know that up to now we had completed a couple of chapters from 11th standard in English series, right? So from today onwards, we will be starting a circular motion. Today will be the first lecture of circular motion. Within 3 days or within max to max 4 days, we will be completing circular motion. Then afterwards, we will start work power energy, okay? Up to now you have watched all these sessions of NLM, kinematics 1D, 2D. If yes, then you will get a very good understanding of what circular motion is all about. Whatever thing we discussed in kinematics, we will be having those things here only, but in angular forms. Okay, just like there we started with a position. Here we will be discussing with the angular position, displacement, angular displacement, velocity, angular velocity, acceleration, angular acceleration. Okay, so let us start now. 1 second, we will be starting. Give me 1 second, beta. And if you want to ask me anything, you're most welcome. You can ask me, there is no issue. So let's start now. I hope my screen is visible to you now. Okay, I hope my screen is visible to you. Okay, so let us start with the circular motion. So 1 second. So the lecture will be in English. As you know that we were started two lectures, one in the English and one in the English. So this one will be in English. Look now. Jasif Naik. Walaikum assalam, beta. Okay. So first thing that we will be discussing here, that what is circular motion? What is circular motion? What is circular motion? Look, to describe circular motion, we need to define a specific point, a reference point. Okay, suppose we are having a reference point. This is my reference point. This reference point would be either in rest or it would be in motion. Okay, this is my reference point. I will write here, this is my reference point. This is one is my reference point. This reference point would be in either at rest or motion. It will be in motion, right? Okay, now if we are having a body, suppose we are having a body like this, right? This is my body, it's my body, and this particular body is moving. This particular body is moving. Okay, it is moving in such a way, in such a way that the distance between a reference point and object remains same. Object remains same. What does it mean? Suppose this is my reference point, this one is my reference point, and this one is my body. It's my body, right? And the distance between a reference point and body, it is, let us suppose, r. Okay, so the body should move in such a way that this r should be constant at every particular point. So that particular type of motion is known as circular motion. So as you know that it will describe its motion in a circular way. Why? Because only in circle the distance between the circumference and this particular point is constant every time. Okay, every time the distance between this particular reference point and the circumference is same throughout this motion. So this particular motion is known as circular motion, and this reference point is known as center. This particular thing is known as center, and the distance between this center and your object is known as radius. In vector forms, you will write down this radius as a radius vector. Okay, so here I will be having my object. Okay, look beta. Look, if we talk about my body is going in an anti-clockwise, if my body is going in this anti-clockwise manner, okay, if my body is describing this anti-clockwise motion, the velocity of my object at that particular instant is a tangential way. That means if we want to get my direction of velocity at this particular motion, at this particular point, we have to make a tangent to it. Okay, and this particular thing is known as tangential. This one is known as tangential velocity. It is tangential velocity. Okay, it is a linear velocity or a tangential velocity. Clear now? So what I had written here, that what is center of motion and what is my radius vector, what is tangential velocity. Okay, the combination of all these things are included in the circular motion. One more thing, that if somebody will ask you, is this circular motion accelerated motion or a non-accelerated motion? Look beta, if we talk about velocity, velocity is a vector quantity. That means if we want to change the vector, there are two ways. One is if we will change its magnitude. Second way is if we will change its direction. Clear? Let us suppose my velocity is 2 meter per second square. That means my magnitude is constant. Let us suppose my magnitude of velocity is constant. But as you can see from this particular figure, that here at first point or at second point or at third point or at fourth point, the velocity direction is always different. No, the direction of velocity is different. That means you will write direction is different. So therefore velocity is not constant. If my velocity is not constant, so that particular type of motion is known as accelerated motion. Very easy to understand. Why circular motion is accelerated motion? Because velocity is not constant. Why velocity is not constant? Because at any instant of time, if we are just studying about direction is changing at every particular instant of time. Direction is changing. If direction is changing, that means my velocity is changing. If velocity is changing, that particular thing is known as accelerated motion. That's why the circular motion is known as accelerated motion. As simple as it is. It is very easy, no? Very easy to understand all these things. Okay. Now, let us define now kinematics. Let us define now kinematics of circular motion. Kinematics of circular motion. That means we need to know now different parameters through which we will understand a circular motion in a better way. Okay, we will be discussing those parameters with the help of which we will be discussing circular motion in a very good way. Okay, first thing is that is angular position. First one is angular position. Angular position. Okay, suppose we are having, we know that now we are having something like this, no? Okay, so what this is, this particular thing represents a circular track, my radius vector. It's my radius vector. Particle is performing anti-clockwise motion. Okay, so origin O, particle is initial, let us suppose particle initial is here, particle finally is here. Okay, I can make this one as a reference line. This particular thing I can make it as a reference line. A reference line simply indicates where from we are just indicating each and every movement, right? It is a reference line. Initially particle is at this particular point here, right? Here. Finally it is here. Finally my particle is this particular point, right? Look now. Look now. If you want to describe now where your particle is, okay, if you want to write now where your particle is, so you will write my particle is making angle theta, my particle is at angle theta from the reference line. If this is my reference line, so my angle is at angle theta from my reference line. Okay, particle is here. So this theta is giving the position. This theta is giving the position of your particle from your reference line. Clear, no? It's my angular position. So angular position, it is basically angle theta. Angular position is what? It is basically angular theta. Very easy to understand. If you know about the kinematics, you should be able to get these things, okay? Now, second point that we should discuss here, that is the angular displacement. That is my angular displacement. Angular displacement. One more thing that you should be aware of, this angular position, it depends on, I can write here, it depends on a reference line. Why? Look now, if my reference line is different now, if let us suppose my reference line is this one now, okay, let us suppose my reference line is this one now my angle theta would be different now. Okay, look now, my angle theta should be different now, theta dash. That means my angular position, it depends on the reference line. If my reference line is this one, so it would be theta. If this one, that theta dash. Just make these things no very clear to you. Okay, look now. Now we are discussing about the angular displacement. Angular displacement. Clear? Suppose my particle is here. Particle is here. Particle go from this reference line to final position theta 1. And secondly means second time, if my particle goes in such a way that, suppose particle is now at a different angle, okay, this one now, okay, that means initially it is angle was theta 1, and finally it is angle is theta final, let us suppose. Clear? From reference line. So what is the net displacement? What is the net displacement now? Clear? That means, that simply indicates that displacement means the positioning of your body is from last to tips. Displacement simply indicates that, look, my particle goes from initial to final here. Clear? It is my first thing right now. The second time, my particle goes from initial to final here now. So what is the displacement between these 2 points? Sir, I guess displacement here delta theta. Delta theta. So angular displacement means delta theta. And delta theta is nothing, it is final angular position minus initial angular position. Clear now? And what is angle? Do you know what is angle? Angle is arc by radius. It is arc by radius from basic mathematics. Very easy to understand, very easy. Displacement and angular displacement, nothing more than that. Okay? And angular displacement, it is independent. This one is independent on a reference line. Look, it only depends on these 2 positions now, one position and second position. It doesn't depends now on this one. It is only between these 2 things. Between these 2 things. Then, if we talk about it is SI unit. If we talk about it is SI unit. So it is SI unit is same as the angle, that is radian. That is a radian. So you can write 2 pi radian. That is 2 pi radian. I guess 2 pi radian is 360 degree. And which will give you one complete revolution. Okay? Or if you write pi radian means 180 degree. That means 1 by 2 revolution. 1 by 2 revolution. Clear? And it doesn't have, it is dimensionless quantity. Dimensionless quantity. Clear now? Dimensionless quantity. But it does possess units, a radian, but it doesn't have any dimension. It is dimensionless quantity. It is angular to get its direction. To get its direction, you need to use the rule of right hand, thumb rule. Right hand thumb rule. And it is an axial vector. You know now we are having 10 types of vectors. So one type is axial vector. That simply indicates if we are having a like this, no? Center, particle is initial is here, particle final is here, right? Look now, initial and final. Particle is going in this way. Particle is going in this way. Take your right hand. Take your right hand. Okay. Now you need to put your right hand. Put your right hand on the initial line. So if my initial is like this, now put your right hand on this one, right? Now go to the final position. Look now, look now, look now. Let's suppose it is like this now. It is like this, right? Initial. And it is my final. Particle is going in anti-clockwise way. Take my right hand. Put my right hand on the initial one, right? My finger should be towards the object. This particular thing now, it should be on the origin. Now look, particle is going in this way, in anti-clockwise way. That means you need to now bend your fingers in the same way. So the thumb will give the direction of your angular displacement. If it is going like this, so my thumb will along this line. This is my thumb. del d theta, or here outwards. Clear? Very easy, no? Today's session I will be keeping this one very short one. Why? Because after a very long period of time I'm just uh, showing here, right? As a showing of here. So that's why I need to be, no, I used to be having a very long classes, but due to my physical classes I'm not having that much of energy. That's why I will keep this one as a short, but in the next class I will be keep this as the same as 1 hour, 1 hour 30 minutes. Okay, some particular points we will discuss here now. Look now, if n revolutions, if we are having n revolutions, look, we know that one revolution is 2 pi radian. One revolution is 2 pi radian. If we multiply it with n, so I will multiply both sides with n, so I will be having here n revolution. N revolution would be 2 pi n radian. 2 pi n radian. So n revolution means 2 pi n radian. Clear, no? Very easy to get this thing done. Very easy. Huh? So what is now time period? What is now time period? What is now time period? What is time period? Denoted with the letter T. Time period, we will denote this particular term, that is time period, with the letter T. I can write here, it is time taken by your particle to complete, no? To complete one revolution. One revolution. Time taken by particle to complete one revolution, that particular time is known as time period. Now we are having frequency. Now we will be having frequency. Either we can denote the frequency by f or n, sometimes by nu. Okay, this one we use in modern physics. In modern physics, mostly. What is frequency? Okay, so you can write frequency simply indicates that revolutions per second. How many revolutions your particle is describing per second. Per second. If we talk about it is units, important, no? It is unit is important. In numerical perspective, it is unit is important. If we talk about the unit of frequency, the unit of frequency, okay, you can write a revolution per second. It is a revolution per second. A revolution per seconds. I can write RPS. Okay, or you can write a revolution per minute. A revolution per minute. A revolution per minute. Okay, so time period is 1 by f or 1 by n. Just note down these particular things. Okay, or I will be sharing these notes to your Telegram group. You can go to my Shakoor Sir Physics Telegram group. There I will share these slides. Don't worry about anything. Okay. Now last point from today's class, that will be, if we are having a motion, simple this motion, right? Look now. Look now. I will take now my reference lines. These are my reference lines. Look now. These are my reference lines. Okay. Look now. This is my origin. I can take it point A. This one as point B. We are having two observers. One observer is at point A and one observer is sitting at point B. Now, my particle is here. Look, my particle is here at this point. Then afterwards, my particle is here. This is my initial point. This is my final point. Initial point and my final point. Okay. If this one is my initial, let us look, my initial point, done. And this one is my final. If we talk about A, so this is my A. If we talk about B, for B, it would be like this. It would be like this, right? Okay, look now. If this distance is R, this will be R. So for my this particular object, its distance will be now 2R. Its distance is 2R. If this angle is alpha, this angle is beta. If this angle is alpha and this angle is beta, this angle is beta. Look now, what is alpha? Alpha is angle. What is angle? Angle means it is arc by radius. Arc by radius. Suppose my arc is S. This is my arc S. Every time the denotation of arc is S. Alpha is arc. What is arc? Arc is S. What is radius? Radius of alpha is R plus R is 2R. 2R. What is beta? Beta is same as angle. Beta is same as angle. What is angle? Angle is arc by radius. This one is my arc by radius. What is arc? Arc is S. What is radius? Radius is R. So alpha came out to be S by 2R. Beta came out to be S by R. Let us divide alpha by beta. So we will be having S by 2R multiplied by R by S. Cancel out, it is 1 by 2. Simply means that beta is equals to 2 times alpha. Beta is 2 times alpha. That simply indicates my angular, look, alpha or beta, both are angular displacements. Both are angular displacements. That means angular displacement depends on position of observer. It depends on position of observer. This point you need to note down that angular displacement, this particular thing, it depends on position of observer. Look, if my observer is here, so angular displacement will be different. If my observer is here, so my angular displacement will be different. Okay, so up to now we discussed about what circular motion is all about. Okay, the second point is what is angular position, what is angular displacement. Now we discussed about this time period, frequency, is angular displacement depending on position of observer or not. Now second class, that means tomorrow. Okay, in second class what we will be discussing, we will discuss about angular velocity. We will discuss angular velocity. We will discuss angular acceleration. Angular acceleration. Okay, in second class we will discuss these things. In third class we will discuss forces. Okay, centripetal force, centrifugal force, these things we will discuss in the third class. And in fourth class, what we will discuss, we will discuss about vertical motion. These things. Okay, in second class angular velocity, angular acceleration. Third class forces, bending of rods, all these things. Fourth class vertical motion. Okay, so for today, thank you. Okay, so if you want to join my Telegram group, okay, Telegram group, you will get their notes You will get their books free, absolutely free. You will get books, you will get notes, you will get videos. Okay, these, and you will connect with me personally, right? If you want to connect with me personally. Okay, it is Shakoor Sir Physics. Shakoor Sir Physics. Telegram group. Okay. If you are having any doubts or anything like that, you can just drop a comment or you can just reach out to me via this. Done. So thank you, beta. Thank you very much for today's class. If you are having any issues or if you want to ask me anything related to your academics or related anything, right? So you are most welcome. So for today, I guess we discussed more than enough. Okay, I will be keeping these classes very short so that you will enjoy each and everything in a very good way, because you are having your board examination coming in next 2 months, right? So you need to be a little bit of slow to get these neat things done. Okay. Thank you, beta. Thank you. Bye. Good night. Take care. Bye, beta.